do a very quick recap. Alright, so we know that your electric current is basically like your energy. Alright, so in order to do work, you need energy. So the amount of electric current affects the work done in an electric circuit. So what do I mean by that? So work done in this case could be how bright your bulb might be. So if your electric component is a bulb, would be brightness of bulb. That is actually the most common and the simplest example I have for you. So there are a few factors, or in very scientific term, they like to use the word variables, that can affect electric current. Right, so they can affect it in the form of the amount of electric current you're flowing through, alright, or the ease of it flowing through. So what are some of these variables? Let's take a look at it. Okay, so we have firstly number of batteries that is arranged in a series circuit. So you know, I keep talking about series and parallel, so perhaps I would just want to introduce to you very quickly what is a series arrangement. Now, so a series arrangement means that there is only one pathway that can be taken in an electric circuit, in short. So this is just a very brief intro. I will talk more about it later. So let me just very quickly draw you a series circuit. So something that's like this. So this is a series circuit, whereas for your parallel, it looks like this. Same number of batteries, however, your bulbs looks like this. So what I like to tell students is, if there is only one pathway, think of wires are like roads or pathways for your electric currents to flow or to travel. If there's only one way in the first case, this is actually series. So I like to think of series. S stands for single pathway. Alright, and parallel on the other hand is not. Okay, so parallel, if you take a look at it, there is actually two pathways. So I can travel from here to here. That's the first pathway. I can also travel this way. Alright, so there's actually two pathways in this case, and we say that this is a parallel circuit. Alright, so now that you've got a quick intro, I can then jump into the variables affecting your electric current. Now, let's talk about the number of batteries, number one. I'm talking about variables affecting electric current. Okay, so we can adjust the brightness. Remember, work done in electric circuit, I talked about, for example, if you want the bulb to be brighter or dimmer, that's a kind of work done when it comes to electric systems. So the first thing you can do is to talk about the number of batteries. So the more, the brighter. The bulb would be when lit up. Okay, that's the first thing. However, alright, you need to take note that you cannot use too many. If not, there will be too much electric current flowing through the filament, causing it to melt. So the more also means that there is more electric current flowing through, which results in a brighter bulb. That's the first thing. Now, take note that if there is too many, the electric current may cause the filament to melt, and this results in your bulb fusing. Alright, we talked about this earlier. Alright, so when this happens, it introduces a gap in the circuit, and we say that the circuit is incomplete. Because of that, electric current can no longer flow. What's the outcome? The bulb will not light up. Okay, just take note of that. Now, the next thing. So with more batteries in a series circuit, the bulb becomes more bright. However, if you add more bulb, the second variable, when you have more bulbs in a series arrangement, okay, it actually becomes dimmer. Now this is not true for parallel, which I will explain to you later. So when you have more bulbs in a series, let's just say you add like 3 bulbs, alright, it becomes less dim. So if I'm going to compare two circuit A and circuit B, now the number of light rays that I'm going to draw gives you a rough idea of how bright it is. So if this is 5 rays, okay, of brightness, this is probably only 2 for each bulb. Now why is this the case? So remember I told you to think about your wires like pathway for your electric current to flow. So in a series arrangement, there is only one way. Remember S for singular. Okay, there's only a single pathway. So all your light bulbs, you can think of it like traffic lights. Okay, so every time it passes through a traffic light, there'll be a brief stop. Okay, so because of that, the flow of it is actually slower or less in that sense. Okay, I mean this is not totally accurate, but it's to help you remember. So in circuit B, there is only one traffic light, so therefore electric current can flow faster. Okay, whereas in A, because there's only one way, it has to go to 3 light bulbs, 3 traffic lights. Alright, and because of that, the flow of current is actually a lot more diminished, slowed down by a lot. Okay, so there is less current flowing through each bulb, and that is the reason why. Okay, so a proper explanation for this, if you were to pen it down, would be as more bulbs are added to a circuit, or rather a series circuit, less electric current flows through each bulb. Thus, the brightness of each bulb decreases. Okay? and that's why. Now, however, now we are going to a new area. What if you add more bulbs in a parallel arrangement? Now, that is a totally different ball game altogether. Now, when you add more bulbs in a parallel arrangement, the brightness does not change at all. It remains the same. Okay? So I'm going to pen it down right now. So when more bulb is added to or in a series arrangement, I think it's better to term it that way, in a parallel arrangement, the brightness of each bulb remains the same. And this is a key idea. Now I'm going to draw you two circuits, in fact 3 circuits for you to see. Now you need to first understand what will happen if you have one bulb only. So a lot of students cannot see that when there is only one bulb, the brightness is the same as having 2 bulbs. So for example, if I only have one bulb, okay, it is 5 rays of light worth of brightness. 1, 2, 3, 4, 5. Now, you need to first understand that a parallel arrangement starts off with a series arrangement. What do I mean by that? So take a look at, this is A, and take a look at B now. So let's just say I'm going to add one more bulb. Now, before I add that one bulb, I'm going to just have one bulb. So I would say that circuit A and circuit B is exactly the same. So the amount of brightness, given the voltage and number of batteries, everything else is the same, is going to be 5 rays of light as well. But wait, I'm going to add one more light bulb arranged in a parallel. Why parallel? Because if you look at bulb 1 and bulb 2, bulb 1 is parallel to bulb 2. According to what I told you earlier, the brightness must be the same. So once again, it should be worth 5 rays of brightness. Now, if I'm going to do a third one, C, same thing. I always start off with a series, in fact, and then I add on another bulb that is parallel to the first one and then the third one. So because when it was a series arrangement, there is 5 rays, the second one should be 5 rays, so should the last one, also 5 rays. Now, take note of this, alright, because there is alternative pathways. Alright, when you take a look at it, okay, I have one pathway here, 2 pathway here, okay, and one more pathway here. Okay, this is a parallel. And here's the wonderful thing about it. If any one of this bulb fails, there is no effect to the remaining 2. So let's go ahead and undo this. So for example, let's just say bulb number 1. I'm going to zoom in, 2, 3. Bulb number 1 fuses. So when it fuses, okay, we say that there is a gap in the circuit, correct? So there's a gap here. Let's go right ahead and erase that. Now, initially, there is a pathway that's going on here. Now, because of the gap that's introduced here, we know that this is no longer possible. Alright? However, for the rest of the circuit, we know that there are alternative ways, okay, to reach the other 2 light bulbs. This is the first way and this is the second way. So as you can see, bulb 2 and bulb 3 are not affected at all. Their brightness will not increase, neither will it decrease because of the fusing of one bulb. They will remain the same. That is the key idea. So be very careful. So in short, this bulb over here is the same brightness as this bulb, this bulb, this bulb, this bulb, given that if the batteries are all the same. Alright, so this is the key idea to take away from bulbs arranged in a parallel arrangement. Now, when would you use this? So you will use this parallel arrangement in a home or in Christmas lights, whereby with one bulb fuses, not the entire home will go out of lights. Okay, so this is something that you need to understand. Okay, so you also need to know about some ways to make use of electricity wisely, and that's because electricity is a very precious source. Why? Now, perhaps a lot of